without further ado, I'm going to introduce Yuri Balashov, who is a professor of philosophy and faculty fellow at the Institute for Artificial Intelligence at the University of Georgia. That's the University of Georgia in the US, not the one in the former Soviet Union. And he's also an ATA certified translator from English into Russian. And I didn't tell him I was going to say this as part of his introduction, but I met Yuri in person about a week ago and had the pleasure of having lunch with him. And one thing he said really stuck out to me and really was, I thought, the definition of a translator. And I don't think I mentioned it at the time, Yuri, but you said something to the effect of, I feel like I'm always and continually a student when I translate. And I think that really exemplifies our place in the whole translation process. We're always learning. We're always, whether it's that type of document we've done over and over. I've done corporate bylaws for 30 years, but I always learn something new. I'm always finding some new way of phrasing something, whether in my source language or my target language. And I think, Yuri, when you mentioned that, I really gained a lot of respect for you. Not that I didn't have respect for you already, but I thought that was a really great statement to make. So we're all students together, and we put ourselves in your hands now for your presentation.
Okay, thanks very much, Robert. So just to make sure everyone is still seeing this screen, right, with the cursor moving, yeah? Okay.
Yes, we are.
Yeah, well, thank you so much. I wanted to add that when I said that at our very pleasant lunch, I really meant that I'm a student of you guys. I'm learning this profession from all of you, and I'd like to continue to be educated on it. So yeah, I mean, this is, let's see, for some reason, oh yeah, here it is, right, now it's working. So this is the University of Georgia where I am, but I've been a proud member of this association for several years now. And I should say that Colorado has become almost a second home for me for a variety of reasons, professional as well as recreational. Yeah, let's put it this way. So it's a great honor to speak at this conference, and thanks so much to the organizers for their effort and time, and for the leadership of the association. So here's my plan for today. I'd like to start with a brief introduction, some of it historical, plus a bit of theory. I don't mean to dwell too much on it, maybe just 15 minutes, and I'll have to move pretty fast, I should say. But if there are any questions, we can come back and look at the details. But let me start by explaining where all this is coming from, because everyone's story is different and mine may be unusual too. I've spent most of my life in academia, doing work primarily in analytic philosophy and philosophy of science. But I've been teaching a lot of logic and philosophy of language lately. So this is Frege, Gottlob Frege, the founding father of philosophy of language. And this is, guess what, a unicorn. Why is it there on the syllabus? Well, because it doesn't exist. That's the most important fact of it, about it, that it doesn't exist. And yes, I do mean to make the slides available. Yeah, sure, no problem. Thank you, Dagmar, for yeah, making this point. So this interest in languages, and I would say passion about languages, both formal and natural, led me to actually learn some linguistics, making use of our great program of study in a second discipline. And also learn more about translation. As I said, I continue doing so every day, and get in touch with these two very different communities, HT and MT, and come to appreciate that human translation is, well, difficult, but also hugely fascinating and intensely human, in the words of two prominent computer scientists. It's also a valuable service. I actually found myself on the supply side of it. But of course, for over 70 years, it's been facing competition from machine translation, whose explicit primary goal, right from the get-go, has been to make human translators irrelevant, by rendering their services unnecessary. That was actually the stated goal. So here's a very striking fact. There's now a whole new generation, Generation Z, right, that grew up thinking of translation not as a matter of service of any sort, but as a matter of pressing a button. Finding the button may actually be the most difficult part of it, right? And sometimes you don't even need to look for it. It's all done in the background. And in general, it may be natural today for an average consumer of translation to think of it as best as a commodity of sorts, not as a service, or at a slightly more enlightened level, think of it as a computational task that is available to everyone basically at a mouse click. So why would anyone pay for that, for a mouse click? This is very difficult to explain to Generation Z, isn't it? Now, of course, we know that the goal of driving human translators out of business has not been realized, but it continues to fuel the rapid development of MT, which has gone through several stages. Actually, it's a very interesting history whose early stage, this one, was bound up with the rise of computing in general. MT was actually one of the first non-digital applications of computers. And also with the development of formal linguistics, it was actually in the making at that time. Interesting to note that this person was hired at MIT to work on machine translation, among other things, which of course he never did, right? But what he actually did had a great influence on early machine translation, in particular on these rule-based transfer systems. So there are three levels at which they can operate more or less. Actually, it's a continuum of sorts, which is often illustrated with this diagram. So as you go up this triangle, it becomes more and more of a paradise for a linguist. And so Chomsky and formal syntax operate at the second level here. So you can imagine some linguist like writing a rule of transfer whereby a certain noun phrase in one language will go to noun phrase in different language with the order reversed. So red wine goes into vin rouge in this order. But of course, it's much more complicated for real life sentences. Actually, the whole process becomes pretty messy pretty soon. And the difficulties like multiply, especially if you go up this triangle. So it was not obvious what to do with these problems, especially in light of like pervasive ambiguity of languages and diversity in types, typological diversity of languages. Perhaps you could just hire more linguists to sort it all out. But then these developments happened in the 90s, which caused a major revolution in MT technologies, this one. So the key paradigm change here was to model new translations after the existing ones by leveraging a massive number of parallel sentences in multiple languages and by applying the resulting probabilistic patterns to new sentences. So ideally, you would want to do all of that without any dictionaries at all, or any linguists for that matter. So there's this famous quote from a researcher named Frederick Jelinek at IBM, which is kind of anecdotal, but I hope it gives an idea of what the project really was. And if you're somewhat mathematical, you can think of it as an application of Bayesian inference and the noisy channel model of communication. So if you want to translate from English to Russian, as I do, for example, you can assume somewhat presumptuously that the English speaker actually wanted to utter or write a Russian sentence, but everything got so distorted in the noisy channel that it became English in the process. And then the goal is to kind of model this distortion in the way things are modeled in noisy channels, and then kind of put it in the language of probabilities, right? There's actually a very beautiful math behind all of this, which involves some controversial figures, as it turns out. So early in the 90s, I think, late 80s, early 90s, they came up with the so-called IBM models for statistical machine translation, eventually based on this interesting algorithm known as the expectation maximization algorithm. So think of it this way. You don't have any dictionaries, right? And you don't have any linguists because you fired them. What you have is several million parallel sentences in, let's say, English and French. But of course, the stupid computer doesn't know that maison translates house rather than blue or the, right? So initially, all these alignments are equally probable, but then you go through the steps of this algorithm, basically recalculating the probabilities and recounting the occurrences of words in these millions of sentences until you have this nice picture where maison is aligned with house and everything else is, right. So then you can assign some numbers to this, like transitions, and that's of course just the first step in a very long process. But that's what it was. But that was not the end of it, because then the dramatic expansion of computing power and the success of deep learning methods in artificial intelligence led to the second major revolution in translation technology, this one, which of course is ongoing, and it's rapidly transforming the field even as we speak. So it's interesting to note that all the landmark achievements in neural machine translation were made basically in a space of 3 years. This includes the regional model, sequence-to-sequence model, as was known at the time. And here is my toy example, English to French. Again, we can come back to this if we need. And then came the attention mechanism, which greatly improved the quality. And then, of course, came the transformer. I would also add word segmentation methods, such as byte pair encoding and sentence piece to the list of landmark achievements, because there is a pressing need in neural machine translation to break words into pieces. Again, we can talk about why and how it goes, but these are some of the ways the system may split the word periodontists in the plural and map it to parodontist. And some of these mappings, some of the alignments should strike you as being very unnatural, especially this one, right? So the one on the right is kind of okay because you can see morphemes mapped into morphemes. But the one on the left is kind of weird. Can you make sense of it outside of machine learning? So the point is that all these ways of splitting are highly efficient in various settings. But the question is whether they can make any like semantic sense, not obviously. And just to indicate that I'm not making it up, here is a visualization of this unnatural segmentation gleaned presumably from attention weights. And this is an opus cat. So I'm not making it up. No, this is actually how it's done. Okay, so going back to my quick history, transformer models remain state of the art in MT, and they continue to beat all the performance records. Nobody knows what the next major breakthrough will be and when to expect it, but the field, of course, is developing at rocket speed. So MT has come a long way, and its quality has become quite stunning, even frightening, I would say. For example, it does a terrific job on these convoluted sentences with center embedding and a lot of possessives, like nested possessives. And I know that you have to take my word for it, but I can say that book in Russian is feminine, and it requires agreement with this verb. And the agreement in gender happens across this long distance, which involves a lot of masculine nouns, such as brother and actor, and then boy. But pretty much all the systems get it right. So they produce this grammatically correct, fluent output. It's quite amazing if you think about it. But the quality also remains very uneven. So the last time I checked, neither Google nor DeepL could handle the kick the bucket thing. Moreover, it's quite fragile. So suppose you make a typo, right? Just a small typo. Well, it results in a reasonably fluent output, which has nothing to do or little to do with the source, right? And also, there are these hallucinations, although there are fewer of them now than before, but this is probably the most famous example. A total garbage on the input side produces this line, right? And you can speculate why, and I actually have some thoughts about it, and we can talk about it, but that's what happened. And it's not because Google wanted to convert you into its religion, as some journalists indicated earlier. No, there is a pretty rational explanation. But it's not my goal to ridicule MT. Actually, it's quite the opposite. As I said, I'm quite stunned with its quality and with the progress made in the last few years. So despite all the hype, so someone drew this curve with the usual cycles of hype. That's how it's always been developing, right? In high tech, in any tech area. Well, there's this blue reality curve, right? And it looks and feels kind of very real, at least to me. And it's putting a lot of pressure on human translators because it keeps raising the bar, even as we speak. So in short, if we want our work to have commercial value, we need to do a lot better than Google Translate or even DeepL. Or maybe we should do something different. And I think it also encourages us to rethink the entire relationship between HT and MT. Historically, it's been uneasy and complicated, as I said. But more and more people are now coming to view it as symbiotic. And we know that this symbiosis is already at work in post-editing, which has become the default work mode for many of us, especially since cat tools now have plugins for popular MT engines. So this brings me finally to the more practical part of my presentation, how to get the most out of this MT output. Well, I think much of it has to do with domain adaptation. So the problem of domain adaptation arises because general purpose MT systems are trained on pretty much everything they can find, scrape, clean, and align from the huge amount of multilingual data. And sometimes it includes like much of the internet, but at the very least, all the available parallel corpora from Europarl to UN to, I don't know, open subtitles, and a lot more, of course. But most of professional human translation is specialized. That's what gives it a real value. So to take a simple example, we know that we need to translate conductor in this passage as music conductor and not electric conductor or rail car conductor. But Google translates it as rail car conductor. And we know that to address your CEO, you need to say, "Good morning, sir," rather than "What's up, dude?" And we know that "bat" means different things in different contexts. Generic MT systems don't always know it, but the desire to automate everything is unstoppable. So I think it's safe to assume that everyone capable of doing it, and that involves, of course, tech giants, custom MT providers, and LSPs, big and small. So everyone is actively working on fine-tuning MT systems to particular areas, such as clinical trials or oil and gas or aerospace engineering or whatnot. So to get back to my example, running this passage through DeepL actually gives a much better result. And it may be due to domain adaptation, which in this case may be boil down to something as simple as taking into account a context that is longer than a sentence, right? That's what it takes, presumably. So I guess it should be clear what I'm kind of warming up to. It should be clear that learning domain-specific terminology and learning from good specialized translation memories is very important. And everyone in the language technology industry is keenly aware of it. Well, what about freelancers? What about us? We are quite often in possession of golden bilingual resources, which result from years of painstaking work and continue to generate steady revenue. So can human translators use these resources in their workflow to improve MT output? Well, the answer is yes. It's becoming increasingly possible, and there are actually several options for it. So I'd like to start by mentioning, linking, and setting aside those that are more advanced, but probably not ideal for individual translators. So that includes special tools and platforms developed by Google and Microsoft, and I'm pretty sure others, that they allow customers, primarily enterprises, not individuals, to train their own domain and language specific neural translation models and deploy them in production. So for example, Google offers AutoML translation as part of their AutoML platform. And Microsoft offers custom translator as part of their Azure Cognitive Services package. And these are just two examples. On the other side of the spectrum, there are startups such as Intento and GT4T, which offer access to multiple MT engines, and sometimes the possibility of choosing the best suggestion for a given segment, based presumably on interesting similarity metrics and other machine learning methods. So it's interesting. So this list of the engines that Intento has access to includes, of course, the usual suspects, but actually a lot more. I was not aware of their existence before I came across this list. There are probably like 50 of them on this list. And sometimes the whole process can be integrated into CAT tools, and the list of these CAT tools is growing. So both Intento and GT4T were reviewed by Joost in his articles. So those who are interested should probably take a look at these excellent reviews. But I'm not going to say anything more about those fairly advanced options. Instead, I want to focus on two usual suspects, which everyone is now talking about, and share my experience with them. I will also try to speculate a bit on what may be happening behind the scenes when you use them. In most cases, it's just a guess, because unlike academic MT research, which is driven by the spirit of open sourcing and sharing the data and all that, industrial applications are, of course, shrouded in the veil of secrecy, even when you can make a more or less educated guess. So please don't quote me on how these things work, because in the end, I don't know. But with that in mind, my goal is to go over these tools. They are popular, and they're easy to use and integrate into the CAT process. And together, they exemplify somewhat different ways in which domain adaptation and fine-tuning can work. So starting with DeepL, it has become the engine of choice for many translators and LSPs. And the main reasons I'm hearing are excellent suggestions for many popular language pairs, better than the competitors. It offers alternative translations, and it has additional cool features, which I'll talk briefly about. All of that probably has to do with the data and not the algorithms. And I'm saying probably because it's a guess, but DeepL, the data that DeepL has, of course, has excellent pedigree in Lingui, its mother company, which is famous for highly contextualized translations of phrases between like 20 plus languages. Some of us may still be using it, right? So this grounding in context is, of course, key to training a good neural translation model. On the other hand, when it comes to algorithms, the differences among the major providers of MT may be insubstantial. Everyone is using the basic transformer architecture nowadays, plus minus different parameter settings and relatively small pipeline modifications. So DeepL currently supports about 25 languages, which of course is not a whole lot. They are adding more, but the process is going slowly because, I mean, when you add another language, you need to train so many models, right, for all the pairs that are added. And the tool, of course, works as a web interface, but you can also download a Windows version or an iOS version, which looks and functions just like the interface, but it's running as a separate app on your computer. There are a few additional features in DeepL I wanted to mention. One of them is tone setting between formal and informal, as illustrated here for German. So that's the difference between the pronouns Sie versus du, and immediately surrounding words, of course. It currently works for 8 or 9 languages where it's needed, not for English, not needed there. Another feature is glossary upload, which is supposed to enforce correct terminology in translation. I should mention that these examples, they're just toy examples. They're for demo purposes. I created them from an existing corpus of medical translations and then made some arbitrary changes here and there. So you should definitely not use this as any kind of medical advice. Yeah, but you can see what's happening, right? When the glossary feature is turned on, the system changes the translation of muscle cell to myocard cell, which is more appropriate in this context. Yeah, so it works. An interesting question is how, right? What goes on behind the scenes during tone adjustment and glossary upload? Well, I mean, I may be unusual, but I'm genuinely interested in such questions. So I searched for the relevant publications, but didn't find any. So I wrote to the DeepL folks asking for the details of their algorithms. Well, they replied very fast by saying, hey, Yuri, you seem to be a good guy, all right, but we're not going to tell you. So the only thing I can do is speculate, and again, I may be wrong in my speculation, but I can think of 2 ways in which both tone adjustment and glossary correction, glossary-based term correction could be done. It could be done at pre or post processing, where the system basically will translate as before in a generic way. So it will translate music conductor as electric conductor, but then the output will be corrected by searching and replacing glossary items. This is not entirely straightforward, actually, and it may involve some statistical alignment or smart use of linguist lexical resources. But then it's not exactly rocket science either. But it could also be done in a more interesting way by incorporating glossaries into the decoding process. Well, if that's what it is, and if anyone knows any details, I'd love to know them too. Please share your knowledge with me. But I should say that it's not easy or straightforward, because if you just add your glossary to the training resources, so if you think of a glossary as just an additional corpus, it's not going to do any good, because these terms, they're without context, and neural machine translation is all about sentential and even longer context. So you need these terms in sentences. Just their terminology will not force the engine to do what you need. I should also add that, unfortunately, glossary support is currently very limited. There are only 10 language pairs for which it works, but DeepL is planning to add more. Finally, I wanted to mention dictionaries and on-the-fly adjustment of translation built into DeepL. Essentially, you can hover over any word in the target window to see its alternative translations. And you can make any other changes in it, and the system will take it from there. The dictionaries, of course, come from DeepL's extensive resources, and adjustment on the fly is probably implemented by means of prefix constraint decoding. Again, it's a speculation, but I think it may be similar to other forms of interactive translation prediction, which was first used in MateCat and then in LILT, and currently in any number of other systems. Okay, so this may be a good juncture to talk a bit more about integrating MT engines into the CAT process. It's actually quite straightforward. MemoQ, for example, so MemoQ offers 24 pre-configured plugins for various popular systems, including, by the way, Intento. Yeah, it's on the screen here. To activate any plugin, you simply need to input the API key in the MT setting window. So it's pretty straightforward. But as a caveat, you need a paid subscription to the service. How much? Well, about $25 per month. And if you want DeepL, you should subscribe to the advanced plan because the starter doesn't have CAT integration. And they will prefer to bill you for the whole year. That's what translates into $22.99 per month. Is it worth it? Well, I guess it depends on your situation, on your language pair and domain and so on, and your workflow. I find it very useful. As I said, I hear many report of the excellent performance of DeepL. You should also keep in mind that subscription guarantees confidentiality of your data, which is to say, the sentences you transmit to the engine, the translations you receive, and anything you upload, including glossaries and memories, DeepL will not use it for any of its own purposes, training or whatnot. It will, of course, be sitting in a cloud somewhere, but it will be protected from any objectionable use. Can you be assured of that? Well, there's no reason. It's an interesting question, all right, but there's no reason to distrust such statements. And there was an interesting discussion of this issue. But of course, you always need to read the fine print, and then I'm not a lawyer. I would say that if you feel comfortable transmitting like personal health information via something like TlueNet, not email, because email doesn't have this added layers of protection, but TlueNet or any other translation management system, you should be equally comfortable using DeepL or Modern MT. But I'm not a lawyer, and this is not legal advice. I should say that the flip side of it is that if you're using free translation services, there's no guarantee, which means that if you don't have a subscription, or if you don't log into the web interface as a user, all bets are off, actually. So once you have your plugin activated in MemoQ or Trados or another CAT tool, you can use it to generate MT suggestions as you go for those segments for which there's no good TM match. So those orange suggestions come from, I think, Google and DeepL. Or if you prefer, you can pre-translate the entire document or several documents by using your settings. In MemoQ, you can also benefit from MT-driven match patch. So basically, it's a fuzzy match repair algorithm. So the idea is that if your fuzzy match cannot be repaired with your term data, then as a next step, MemoQ will query your chosen MT engine for the translation of the non-matching substring of words. And other CAT tools capable of fuzzy match repair may offer similar benefits. I'm pretty sure. Yeah. So obviously, all of that is convenient and efficient, but there are some trade-offs when it comes to using MT engines within versus outside CAT tools. For example, if you use DeepL inside MemoQ, you cannot benefit from the additional cool features I just mentioned. The system will simply give you what it takes to be the single best translation with no alternatives, no dictionary lookup, and no online adaptation to your corrections. So you just take it from there and post-edit more or less from start to finish. If you really want these extras, you need to open the web interface or the desktop app in parallel, hopefully on a separate monitor, and use it when needed. In that case, don't forget to log in, of course, if you want your data to remain confidential. All right, turning now to Modern MT. How are we doing in terms of time? I think we're doing reasonably well. Yeah, I hope. So Modern MT actually was born on the same year. So it's kind of interesting. All these developments happened almost simultaneously. And it's another recent success story, but this time resulting from a very fruitful symbiosis of academic MT research with important commercial developments. So academic research, of course, by definition, is open source. Not entirely open anymore in the case of Modern MT, I should say, but it is a product of collaboration among several entities, including, first of all, Translated, which I think still holds a majority of the shares in Modern MT. And of course, it's famous for My Memory project and also for MateCat, predecessor of Modern MT. So Translated is one source of this project. TAUS is another, but then there's also the University of Trento and the University of Edinburgh and the European Commission, and importantly, Fondazione Bruno Kessler. What makes Modern MT different from DeepL is its ability to learn from your memories and from your corrections, and to take into account the context, a pretty broad context, sometimes the context of the whole document. So interestingly, this is done in a way different from standard domain adaptation. And it's done at a fraction, a small fraction of the computational cost, which means very fast and inexpensive. So just for contrast, standard domain adaptation is basically a two-step process, right? First, you generate a generic model, or maybe you just take it from Google or Microsoft, and then you fine-tune it with your much smaller in-domain resources, essentially by going through more cycles of the training process. So sometimes it's the very same training process that goes into the first step, but more often than not, it's more like focused and aggressive because the size of the in-domain data is much smaller than, of course, than the generic data by several orders of magnitude. So to make up for it, you either need to increase what is called the learning rate, or maybe go through more training epochs. And it's actually not so easy because there's a danger of overfeeding. So the system may end up simply memorizing your in-domain data, but it ends up being unable to generalize to new sentences. So you kind of need to steal a middle course between undertraining and overfeeding. But that's how it's done in, for example, Microsoft Custom Translator, or in OpusCat for that matter. Modern MT also makes use of your memories, but it starts by matching them to the context of the current segment. So the current segment is the sentence that you open for translation. But it may also include surrounding segments. And most importantly, sometimes the entire document serves as a context for every such query. So what happens next? Well, the system retrieves several translation units from your memories or from a single chosen memory and ranks them by similarity to the current context, which is just a feature vector. And then it uses this information to set dynamically the hyperparameters of the neural network, which is needed to adapt a temporary copy of the very same stable generic model to the current context. And then the system uses the retrieved translation units to quickly fine-tune the model. And it really happens at a fraction of a second. It's like in einem Augenblick, very fast, which then generates a suggestion that is hopefully closer in terminology and style to the current context. The translator, of course, may accept or post-edit it, and the confirmed segment is added to the resource memory. So then the copy of the model is discarded and the system moves to the second segment. Or at least that's as much as I could glean from this 5-year-old paper. 5 years is almost an eternity for neural machine translation, where the concept was described. And from a slightly more recent patent application, so the date of the patent is 21, but it was actually filed in 2018. And all my attempts to extract more information from the modern MT folks have not been very successful so far. Obviously, there were a lot of developments and a lot of changes, but maybe the idea remains the same cool idea. I think it's a pretty cool idea, actually. Does it actually work? Well, yeah, I mean, I can report anecdotally that modern MT suggestions are indeed informed by memories. And I can't really show a real life example, but I have my toy examples, which, as I said, I cooked up for demo purposes from this corpus, from the French to English part of it. Yeah, you can get it on this, what is it, Euro, yeah, Opus site. Yes, here it is. So I discovered, for example, that after consuming my toy memory, modern MT corrected its output by putting this red clause up front, which no other MT engine did. And it could only take it from my toy memory. Yeah, that's what's in the memory. And it also used a more precise technical term, also picked up from the memory. So it works. Yeah, there's no doubt that it does work. I also wanted to mention that modern MT has a much broader coverage, language coverage. It includes about 50 languages, including some Asian languages and languages with a very different, like syntactic and other structure, typologically different languages. 2 versions of Norwegian, importantly. How much does it cost? Well, 25 bucks, 25 bucks per month. So I'd say, based on my experience, modern MT and DeepL nicely complement each other in terms of their overall quality and various features, including dynamic adaptation. Is it possible to use both of them in your workflow? Well, yes, of course. You can actually add, for example, basic Google Cloud as a baseline of sorts, and then activate all 3 in memo queue and hit the road. Moreover, you can designate one engine for pre-translation, for example, Google, another one for match patch, and keep modern MT for online adaptation. So when everything is said and done, you can see all 3 suggestions coming from different MT engines in your translation results pane. And they are interestingly different. So if you just look at the starting, well, the first few words of them, you see the difference. So as I said, this last one where consistent with the clinical effects is put up front, is informed by a translation memory, and I think it comes from modern MT. Here's another interesting trio. I don't remember what is what, but I would guess that the first one is maybe Google Basic. Is a solution for infusion, the active substance of which is, and I can't even pronounce this, A-alpha. It kind of sounds awkward. Yeah, the second one is a little better, but I think the third one is the best. But of course, you can see all of them. And in addition, you have translation memory matches and glossary hits. So you can get the best of all worlds. Yeah. All right. Well, that leaves out many other interesting tools, such as Microsoft Custom and Opus Cat and a lot more. So let me say that my selection was, of course, subjective, based on my own experience and information, and also my interests, research interests. Your experience may be different. I think you are in the best position to evaluate the output of a fine-tuned model and decide whether you can use a particular fine-tuned engine in your work. All right. Well, that's all. Thank you very much. Appreciate your coming.
Thank you very much, Yuri. A really fascinating presentation. So feel free, I have a question or two, but feel free to everyone, you can either unmute
And,
yourself and
and I
we'll
think I'll keep
recognize
my
you.
slides just in case I need to go back to them. And I'm seeing the
Oh,
chat.
sure.
So yeah.
Okay. Yeah, feel free to put your question in the chat, or you can unmute yourself and we'll recognize you and call on you to ask a question. So I think it's really interesting the notion of tone setting. Um, and boy, I don't know exactly how to phrase this comment, or maybe it's a question, but tone setting, when you look at, say, formal versus informal, I know you have that in Russian and we have it in French and Spanish and Romance languages, I believe in German as well. Um, but what about tone setting that's more semantic rather than, or excuse me, syntactic? Like the example you used about "Hey, dude" versus "Good morning, sir." And little adaptations like that may not be reflected uh, so well in the source language, but are more appropriate in the target. Do you have any thoughts on that? Or is that going to remain the province of human translators for quite a while?
Well, I would say yes and no. So the process that's operative here is probably like more like an old fashioned string matching algorithm that just takes into account the co-occurrence of certain terms. So it's not like a deep learning process. But when it comes to semantic similarities, of course, um, with the most recent developments in language modeling and closely related areas, it's possible to compare entire sentences or maybe long phrases by embedding them in this space of like 500 or 1,000 dimensions and then compare the resulting vectors. So that's how you get the sense of semantic similarity. But I think you were wondering about the syntactic aspect of it. So that may be something slightly different, but maybe related. I would say that there are amazing things happening like before our eyes in language modeling, and in particular syntactic relations, including long-range dependencies, can be learned. We know it from various works. They can be learned just from pure strings of text, just by some version of a neural network based process. So I would say that whether it's can be categorized as syntactic or more semantic, it's all up for grabs in neural language modeling. So the question, I guess, is whether it can be immediately implemented in a setting like this and used by us. This I'm less sure about, although I'm hearing that Intento, for example, so in the Intento process may be informed by this sort of smarter similarity metrics involving some deep learning methods. Whether it works sentence by sentence or whether it starts by kind of getting a sense of the whole document, I'm less sure. But I guess that's a very verbose, convoluted attempt to answer your question, Robert. I think nothing is impossible, although some of what you said may not still be available for us in these frameworks of DeepL and modern MT and so on. Nothing is impossible. Yeah, I would say anything that you can imagine is probably something that people are working on.
Yeah, certainly. And I shared the story with you, Yuri, recently about. I believe I shared this when I got started in translation. The first 2 or 3 years, I had a good friend who was a computer and electrical engineer, and he said, "Oh, you're going to be out of business in 4 or 5 years." um, and it's real easy to look at anecdotes and still say that, but I think machine translation is something watch out for and be aware of. And I think many of us who have survived in the profession over the past, these improvements that have been made in MT over the past 20, 30 years, we've specialized, we've become more creative, or morphed into, or transitioned into more creative types of fields. And I think that's important. So it's a big question, where are things going? And I forget the exact wording you used, but one of your slides when you spoke about how quickly things evolve really resonates with me, because from one day to the next we can see really, and from one website or one engine to the next we see very shocking improvements. So yeah, it's an area we need to consider and observe and somehow integrate into our work. Um, Again, feel free to put questions in the chat, but if there are no other questions, I do have one other question. And you seem to favor MemoQ for, is that the tool that you use and mostly integrate with some of
Yeah,
these
that
engines?
that just happens to be the tool I use.
Mm-hmm.
So I should say that lots of other tools have similar features, and yeah, Trados definitely does. All these engines can be integrated into the Trados process,
Yeah.
and MemSource and a lot more. So it's just I just happen to be familiar with MemoQ.
Sure, that's fine.
That's
I was
why I
going to
chose
ask
it.
about Trados,
No,
yeah, and I assumed that the other CAT software out there, that they would all
certainly.
integrate pretty well. So
Yeah.
great, great. Any other questions or comments, please? Anyone? Feel free to unmute yourself. And Dagmar, go ahead and unmute yourself if you like. I see your virtual hand raised. You're so polite.
Thank you. Well, I have not forgotten to be a lifelong learner, which means, I'm always a student, not just a teacher. No, but thank you very much for this presentation. I put in the chat, my head is still spinning. I'm from a 60s girl. I'm still trying to catch up. But that's not what I'm here to talk about. What really impresses and scares me is the implementation of AI, and to see where we are, and just look up like a year before, and the steps that can be taken, in particular also on tone settings. I do remember the very first models, and there was just no way of sensing a certain tone, and we had to. I'm talking now not the written word, but the tone, in a conversation, and I don't know if others feel the same way. Maybe the younger folks among us, for them it's like everyday material. But to me, this is really something that I see as a big danger, not just the machine translation, but pairing it with AI. It's like, whoa, that's probably really, really wiping us out, not knowing, am I talking to a machine? Am I talking to a person? And so forth.
Yeah, which sounds like, thank you so much, Dagmar. It sounds like a version of the Turing test, and maybe the systems nowadays are capable of passing it or almost passing it. Especially if you think of monolingual language modeling, such as implemented in GPT-3 and related models, they can write like B- essays for you, right? So our students can just explain in plain language what they need, and then hit the button, and here comes out a paper. So yeah, I mean, that's amazing and scary, but it's not so like it's people arguing about the limits of all that, and some people think that maybe these models are hitting some kind of limit. One interesting side note is whether, so in our work, we combine hopefully translation memories with MT suggestions. But some people, most importantly, sorry, Johann Hummel, who actually gave us, so he's the creator of Trados. So he is one of those who gave us translation memory, and now he thinks that it's time to retire translation memory. So his reasons are that AI informed models became so good that there's no need for translation memory. But I personally think that he is wrong on that count. I think translation memories are needed. Well, we just know, right, that they are needed. There is no way around them. And part of the reason is that this neural-based translation predictions may be just way too creative sometimes. So even though they are fluent, they may move a bit farther than we need from the right tone or the right setting or the right context. And in any case, the client may want translation memory suggestions to be enforced. They may not want us to be like generating versions of these translations, right? They want us to follow the templates. And that sort of sounds like the good old-fashioned symbolic process rather than deep learning based. So I think that kind of suggests that maybe a combination of both is what we should be harnessing. It's not just the sheer power of deep neural networks. No, we need this symbolic part. And we as humans are, of course, best at processing and leveraging these symbols, right? Because they're all represented in our brain in the right way, not in terms of these subword pieces, but in the grammatically informed way.
Yeah, you know, excuse me. One issue I find, and I think we probably all find this, is that. Oh, I'm sorry, Dagmar. Did you have a follow up? No. Okay, sorry. Um, the an issue we find is that MT and the quality of MT is not monolithic. It's not the same as you've very ably pointed out, Yuri. It's not the same from Google Translate to DeepL to some of the more advanced systems, and even taking into account, say, the customized systems that have been developed over decades. I'm thinking of the Pan American Health Organization's in house MT system, which I know about just anecdotally and through some colleagues. I haven't worked with it myself, but it's really challenging when a customer, when a vendor, say a translation company, presents to the end client, well, you can do MT for 15 cents a word, or you can do human translation for 20 cents a word. And well, geez, what kind of business person is going to choose human translation when it's more expensive? That's, that's almost like saying, well, someone's going to build a deck for you onto your house, and, you can, now obviously if they quote you $500 for any decent size of deck with any kinds of volume of materials, you're going to question $500. But if someone quotes you $20,000 and someone else quotes you $17,000, you're going to think, okay, those are both in the right range, and you're probably going to go with the cheaper one, unless you can determine the quality and the differences. And I think a lot of the vendors out there, meaning translation providers as companies, not we practitioners, I think they tend to paint with a broad brush as to the differences between human translation and machine translation, and that's unfortunate. And that's a discussion that needs to be had, but I think it's one that is probably, the horse has probably left the gate already. So, but it's a challenge, and it's something we have to keep in mind, and even educate the staff at translation providers, at translation companies, about the differences and the shortcomings of some of the, even the advanced machine translation engines. So that's a real challenge for us.
Oh yeah, and
Jennifer.
I
Oh,
fully agree.
sorry.
Sorry, go
Go ahead.
ahead. I was just
No,
going to say
please.
that, yeah, I mean, education is an important part of it, and it's great that there are projects along these lines, such as those developed by Lynn Balker and others, having to do with exactly that, educating the users of machine translation about the power, but also the limits of this technology. So yeah, and we need to be more active in doing that as well.
Yeah, Jennifer put in the chat a Spanish phrase, but it's like being penny wise and pound foolish, I guess is the equivalent I would say in English. You can cut corners, but and this is the problem with at least this is the market I'm familiar with the American market, is that even among human translators, a a buyer, a client is going to look at translator X charging 20 cents a word and translator Y charging 15, just to use the numbers I mentioned before. And they're going to say, oh, well, salt is salt, pepper is pepper, steak is steak, right? So we're going to commoditize it and we're going to buy the cheaper one. But when your company reputation, when a multi-million dollar project rests on it, when the contract terms rest on it, are you going to trust it? If if it comes down to your own money personally, are you going to trust to machine translation? Say if you're signing an investment contract, what's and you have it translated so that you can understand what's going on. Well, are you going to trust that translation if it's free? I just don't see the business sense in doing that. But so many businesses in the U.S. Just the individuals are not aware of the intricacies and the issues surrounding translation and language translation between various languages. So I know I'm preaching to the choir here, but that's the
Sure,
way
no,
I
no,
see
absolutely,
it.
you're absolutely right, and that sort of explains why so much effort is going into MT evaluation research, improving the metrics for MT quality, and yeah, I mean there are interesting studies, although there should be more of them, comparing the differences between different human translations to the differences between a human and an MT translation, with some somewhat surprising results sometimes. Yeah, there's a lot of action there, actually.
Very interesting. Any other questions or comments, please? Anyone? No? We have a few minutes left. No? Well, if there are no further comments, Yuri, thank you so much for this presentation. It's very, very informative, and I think this is an area that we as professionals need to be aware of moving forward. And certainly, it's a challenge, not just to sell our services and survive on a financial level, but to garner respect for our profession, and it's one that's affecting interpreters nowadays. It's one that is affecting translators. And I'll just tell an anecdote that I don't think I shared with you, Yuri, when we talked previously. I volunteer at Denver International Airport, and I speak Spanish and French, so that covers a lot of people in the world. I do get quite a few Hispanic folks Spanish speakers who come through and don't speak much English and are more comfortable speaking in Spanish. So I have that covered. I can muddle through in a little bit of Russian, so sometimes I can handle that. But I had two Turkish travelers who spoke Turkish come through, and they were using an app on their phone that clearly they had used before, and I could understand zero of what it provided in the English translation, and I couldn't even convey to them. I don't even know if shrugging your shoulders is the appropriate physical sign for for that part of the world. But I just was shaking my head no. I could not understand any of what it quote unquote translated into English from Turkish, and so the guy was frustrated. He tried again to put something else into the little translation engine on his phone or his iPad, and still again it was gibberish to me, even thinking in the domain of, okay, he's asking about some question in the airport, where are the restrooms, where is this or that, and we had to resort to using language line services, which the airport uses for those kinds of situations. But yeah, there's just such a wide range, and I think we're decades away from that kind of power being put on our phones and on our in our hands, in our universal translators. If you're a Star Trek fan, where you just speak in one language and everyone hears in their own language. So we're a long ways away from that, but it is something to be aware of, these changes in the industry and in the technology. So thank you very much for bringing this to us, and we look forward to seeing you at other CTA events, Yuri, and thank you for being a great
Thank you so much,
CTA
everyone,
member.
for coming. I do appreciate your attention and your questions. Thank you.